Hi, this is Giridhar from eMath. As eMath, this video series is an initiative of a free chapter-wise revision for all SSLC students of Karnataka. In this video, let's revise the chapter Coordinate Geometry. So, the chapter 7 Coordinate Geometry. In this chapter, we come across three different formulae, namely distance formula, section formula, and area of a triangle. Let's see one after the other. The first one is about distance formula. So if there are 2 points, namely a of x1, y1 and b of x2, y2 in the two-dimensional geometry, two-dimensional coordinate axis, then the distance between the 2 points called PQ is given by the formula. PQ will be equal to root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. Then comes section formula. According to this formula, we have the coordinates of the point P of x, y, which divides the line segment joining the points A of x1, y1 and B of x2, y2 that divides internally in the ratio m1 is to m2 are given by. So this is the formula. P of x, y will be equal to m1 x2 plus m2 x1 whole divided by m1 plus m2, comma m1 y2 plus m2 y1 divided by m1 plus m2. This is the x coordinate and this is the y coordinate. So these are the coordinates of the section formula. Alright. Then comes the third formula called area of a triangle. Usually area of a triangle can be found by using the formula area of a triangle is equal to half into base into height, but in coordinate geometry we can also find out the area of a triangle by using this formula also. The formula says that area of a triangle is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. Since it is the area, we need to express it in terms of square units, right? So where these x1, y1, x2, y2 and x3, y3, they are the three vertices of a triangle. Okay, let's look at the illustrations. Illustration 1, it says if the points a of minus 2, 1, b of a, b and c of 4, 1 are collinear and a minus b equal to 1, find the values of a and b. This is what the question is, right? So they have given the three different coordinates points a, b, c, and they are telling that these are collinear to each other, and they have given a condition also, and that is a minus b equal to 1. Okay, now we need to find the values of a and b. Let's see how we do it. So solution goes here. So we know that if 3 points are collinear, then the area of a triangle is equal to 0, right? So what if the 3 points are collinear? Then the area of a triangle equal to 0. So now what we do is take the area of a triangle formula and equate it to 0. Yes, so this is the area of a triangle formula, and then area is equal to, after substitution we will equate this whole thing to 0. Okay, and then find the values of a and b by using this condition again. Okay, now area will be equal to half times, so this is our a, b, c points, right? So this is x1, y1, this is x2, y2 and this is x3, y3. So by substituting all these values, the equation will be area is equal to 1 by 2 times minus 2 into b minus 1 plus a into minus 1 plus 1 plus 4 into 1 minus b. After simplifying, we get a half into minus 2b plus 2 plus 0 plus 4 minus 4b, and this is the whole area of rectangle, area of a triangle, and you see this is equated to 0 over here, right? Then after simplification we get 0 is equal to minus 6b plus 6, grouping all the like terms and unlike terms we get this thing, and then finally the value of b will be equal to 1, right? So by substituting all the values of area of a triangle we get the value of b, and then they have given one more condition, namely a minus b equal to 1, right? Since a minus b equal to 1 which is given to us, we can find the value of a, that is in place of b, if I replace 1 and shift towards right hand side, what do we get? It's a is equal to 1 plus 1 which is 2. Therefore the value of a is 2 and the value of b is 1. So 2, 1 are our solution. Okay. Then let's look at the illustration 2. It says if A and B are the points given by -2, -2 and 2, -4 respectively, then find the coordinates of P such that AP is equal to 3 by 7 AB and P lies on the line segment AB, they are telling. So if this is the straight line AB, P is some point which lies on the line segment AB, and the coordinates of A and B are given over here, and we don't know the coordinates of P, that is x, y, right? So let's see how we do it. It is also given that this is the condition. So firstly we take this condition and use it in the proper way. Okay. So AP will be equal to 3 by 7 into AB, which implies that AB by AP, if we cross multiply this to here, and 3 by 7 is going to cross multiply to the left hand side, so that what we get is AB by AP will be equal to 7 by 3, and then AP plus, according to the diagram, we can write this AB as AP plus PB and then divide by AP as it is in the denominator. That will be equal to 7 by 3. And in the next step, we can just split this denominator so that we get AP by AP plus PB by AP will be equal to 7 by 3. Here we can easily cancel out this AP by AP and make equal to 1. So PB by AP will be equal to 7 by 3, and this 1 is shifted to right hand side and becomes -1, and 7 by 3 minus 1 will be equal to 7 minus 3, which is 4 by 3, right? 4 by 3. So taking the reciprocals on both sides, we get AP by PB will be equal to 3 by 4. So our ratio is 3:4. AP is to PB will be equal to 3:4. So using this particular ratio, we are now finding the coordinates of P. Okay, so let's see how we do it. Yeah, so firstly we'll assume like this: let P of x, y be the point which divides the line joining the points A of -2, -2 and B of 2, -4 in the ratio 3:4. This ratio is what we have got just now, right? Then yeah, we have the section formula, namely P of x, y will be equal to m1 x2 plus m2 x1 divided by m1 plus m2, m1 y2 plus m2 y1 divided by m1 plus m2. And the next step, we'll just have to substitute the values. Okay, so this is our x1 y1 and point B is our x2 y2, and 3:4 ratio is our m1 and this is our m2. Okay, so by substituting we get this step, and in the next step after simplification, we get is -2 by 7, -20 by 7. So these are the coordinates of the point P, right? So this is how we can find the coordinates of the point P by using the section formula. Thank you. We will get back to you with the revision of next chapters.